Hello children, let us see the today's agenda. Dear children, in today's class, first we discuss what actually thrust is and the units of thrust. Then we discuss what is a pressure and the units of the pressure. Especially we discuss the how units of pressure are interrelated. Then we discuss the factors on which pressure depends. Then finally, in today's class, we discuss the application part of the pressure. I mean applications based on how a pressure is related to the surface area. So, before going to discuss what actual thrust is, children, let us recall what actually force is. So, what force can do, these students? So, force can change the shape of an object, size of an object, even force can change the direction, and moreover force can change the state of an object. I mean force can bring the object from rest to motion and even from motion to rest also. So, with that knowledge, now let us proceed and let us learn what actually thrust is. So, first let us see a thrust. So, after learning thrust, we get a command on pressure is. Children, is there any particular rule so that we can say that force should act in only one particular direction? No, it is not that. Force can act on any object in any direction. There is no rule, right? We cannot say that only force should act only in a west direction, only force should act in only east direction. It is not like that. If you can take an object and that object, force can act in any direction. For suppose, let us take here, it is an object, right? Yes. On this object, let us say F1 force is acting. Okay, it can act. Okay, and here is in this direction, one more force is acting. Let us say F2 force. Yes, it can act. Let us take one more force. Here it is acting, F3 force. Of course, it can act. We cannot say that no, it should not act. And here, one more force, F4 is acting. Children, just try to understand. Try to notice the diagram here. F1, F2, F3, F4. These all are the forces acting on the same body. What is the common point? Yes, all are forces only. But is there any difference? Is any force special among all these four forces? Come on, think. Got it? Yes, you are right. Yes, that is force F4 is somewhat special. Why it is somewhat special, children? Just look at this. This is a force which is acting perpendicular to the surface, that is 90 degrees. So, this force only we can call it as a thrust. We can call it as a thrust. So, here children, again I am saying one thing. Thrust is nothing but force only. These students, as thrust is nothing but force only, why we should call with a special name so-called thrust? Because that is a specialty. What is that specialty? Which always acts perpendicular to the surface. So, we can define, thereby we can define thrust. How can we define the children thrust? The force acting perpendicular to the surface. The force which is acting normal to the surface is called thrust. So, whenever we get term called thrust, you should think that the force which is acting perpendicular to the surface. Now, let us see. Yes, children, and one more very important thing. Is thrust scalar or vector? Come on, think. Yes, in a laws of motion, we discussed force as a vector only. But what can you say about thrust? Yes, thrust is nothing but force only. So, obviously, thrust also vector quantity. Thrust also vector quantity. And moreover, when we discuss about the units, children, you will get surprised. Why? Because as thrust is a vector quantity, what are the units which we have for a vector for a force? Same units we have for thrust also. Children, in SI system, let us see. Next, we will learn about units of thrust. So here in SI system, the units are Newton. Units are Newton. Children, whenever we are writing the full name of the unit, first letter must be a small letter. This is a point which we discussed in the guidelines to write the units in a first chapter. Okay, fine. And the symbol can be written capital N. Why? Because it is a scientist name. If not, we cannot use a capital letter. And what are the CGS units? The CGS units of thrust are dyne. Children, I repeat here. What is thrust? The force acting perpendicular to the surface is called thrust, and it is a vector quantity. Its SI units are Newton and the CGS units are dyne. Dear children, how Newton and dyne related? Come on, think. 1 Newton is equal to how many dynes? Just pause the video. Try to comment your answer. Come on, children. 1 Newton is equal to how many dynes? This we discussed in the laws of motion. Got it? Yes. If my guess is right, yes, you have commented correct answer. What is that, children? Let me tell you here. 1 Newton is equal to 10 power 5 dyne. Or we also can write here 1 dyne is equal to 10 power minus 5 newtons. Children, it's a very important. And the children, other than this, we also have gravitational units of force. Gravitational units. We have gravitational units of force. Same thing we can discuss for thrust also. So, let us see once again gravitational units. We can see the gravitational units. Children, it's very important. Gravitational units. So, here the first one is kgf. Hey, when I say kgf, you may to your mind the picture movie called Yash picture, right? Yes, it's a wonderful movie, no doubt about it. But here this is not that actually movie name here. It's okay now. kgf, kilogram force. Children, what actually kgf is? How to define? Let us see one second, children. Here is, let us say here is an earth surface. Earth surface in a simple way. How can we define? Here is a body of mass 1 kg. So, here is a body of mass 1 kg. Dear children, we know that definitely there will be a force act on this body, right? What is that force? Gravitational force. What is the nature of gravitational force, dear children? Gravitational force is always attractive in nature. So, children, the force of gravity acting on a body of mass 1 kg is called 1 kgf. Children, I repeat once again. The force of gravity, the gravitational force acting on a body of mass 1 kg is called 1 kgf. Got it? Fine. So, here how kgf is related to the Newton is a very important examination point of view. 1 kgf is equal to 9.8 Newton. But dear children, sometimes whenever we are doing the numericals, so this can be taken as a 10 newtons approximately. But in exam, if they'll ask you 1 kgf is equal to how many newtons, you better write 9.8 newtons only. And the second one is gram force. Children, with the concept of kgf, can you try to think what actually gram force can be? Yes. In the place of 1 kg, let us take only 1 gram mass. So, children, the force of attraction, the gravitational force acting on a body of mass 1 gram is called 1 gram force. Children, here 1 gram force is equal to the 980 dyne. 980 dyne. So, this is a basic information regarding the thrust. But dear children, on which factors does the effect of thrust depend? It's very important. This is very important. The factor on which, children, hope you have copied. Okay. Anyhow, let me take this side. Okay. And which factors does the impact, the effect of thrust depend? So, it's very important. So, here effect of surface area. So, it's very important. So, effect of thrust depends on surface area. But how? So, let us say, children, for example, let us take a person, his weight is, for example, what can we say that some 16 Newton, let us say that. His weight is, let us just example, just let us say it's a 16 Newton, for example. And here is, let us say, here is sand Of course, here also sand floor only. It's very important to understand. So here the person with some 70 Newton, let us say 70 Newton is standing. Okay. Now let us say same identical person is sleeping. Sleeping means it's not like just simply lying on the surface of the sand, let us say that. Simply he is lying, let us say something like this, he is lying. Children, can you notice any difference in both the cases? Yes, we can notice what happened. So here the person where he is standing on sand surface, what will happen? His feet will get into the sand. Am I right? I mean, we can say his feet means he can sink little bit into the sand. But whereas here in the case of let us say it's the second case. In the first case, his feet will go little bit inside of the sand. But whereas in the second case, it won't happen like that. What is the reason? Children, here weight is 70 Newton only. Here weight also 70 Newton only. But what makes the difference, children? Here, look at the surface area on which it is acting. Only feet. This one and this one only. But here, whole body. So, on this much surface area is it acting. Which means what here? More the surface area, less the impact of thrust. Less the surface area, more the impact of thrust. This is very, very, very important. So, the thrust, the effect of the thrust depends on the surface area. This is very, 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 very important. Fine. Now, we discuss pressure. We discuss the pressure. Children, here I have a small question. Can we apply pressure? Can we apply pressure? Just try to understand. Can we apply pressure? Yes or no? That's it. So, your answer should be yes or no. If so, just give an example. In your life, in your daily life, where have you applied the pressure? Come on, children. Pause the video and try to comment your answer. Can we apply the pressure? Yes or no? That's it. I know, I'm not expecting any explanation from you all. Just tell me, can we apply the pressure or not? If you ask me the same question, yeah, hope you have mentioned the answer. Yes. If you will ask the same question to me, I can say that, sorry, I can't exert the pressure. I cannot exert the pressure. Means what? Directly we cannot. You make it out. Sir, what is that? Yes, we can exert the pressure like this. Of course. But here I have a question. Are you applying pressure or force? Come on, think. Yes, we have to think. Come on. You take any object. Yes, if I ask you, explain how can you exert the pressure. Immediately what you do? You take one object and you try to do like this. Yes, sir. This is how I am exerting the pressure, you tell. But my question is that, in this case, are you applying force or pressure? Now here confusion starts. Children, pressure is what? It is the impact of force only. How means what we can say, see whether it is more or less means pressure, what we can say force, if you can talk in terms of area, in terms of surface area, that only we can call it as a pressure actually. So separately we cannot apply a pressure, children. Whatever we are applying is force only, but that force is measured per a given area. This is very, very important. Don't get confused. Don't get confused. Okay, fine. Let us learn what actually pressure is. Children, here we see the definition of pressure, units of pressure and the relation. Then we discuss on which factors does the pressure depend. Okay, fine. So children, let us take some surface area. Okay, here is surface area which we have taken. Okay, so on this surface area, force is acting. How? Perpendicular to the surface. Come on, children. If a force is acting perpendicular to the surface, it is given a special name. What is called? What is that special name? Thrust, right. So I can say that here is thrust acting. the thrust. So when I mention thrust is acting, again I no need to mention it is perpendicular to the surface only. Why? If it is acting perpendicular to the surface only, it is called as thrust. Okay, fine. Children, of course, on this entire surface, thrust is acting. On entire surface, the thrust is acting. But I am very much interested to calculate the thrust acting on this area. Let us suppose this is 1 meter, okay, and here is also 1 meter on this area only. Means on this surface, how much thrust is acting, that I want to calculate. Look at here. So here 1 meter length, 1 meter width. So then what is the area of this surface, children? 1 meter square. 1 meter square. Now here let us say this is thrust acting, here thrust acting. Now children, so this thrust, especially here, this thrust acting per this unit area is called pressure. How much thrust is acting per a unit area is called pressure. So it's simple. Children, thrust can act on entire surface, but we are very much interested to calculate how much thrust is acting per unit area only. For that only, a special name is given called pressure. Pressure, children. So what is the pressure? Thrust acting per unit area. Let us write the definition, children. It's very important. Come on, note down. Pressure. So children, thrust acting per unit area is called pressure. So pressure can be written thrust by area. Thrust by area. Children, some textbooks it is given force by area also. Nothing is wrong in it. Okay. So in symbols also we can express P is equal to T by A, or we also can write F by A. T by A or F by A. Now let us see the units, children. It's very important. It's a very important. And here is a pressure is a scalar or a vector. Children, it is a scalar. In detail we will discuss in further classes why it is a scalar only. Just for today, just note down pressure is a scalar. Okay, fine. And here SI units, children. First let us see what are the SI units of the pressure. It's simple. How to write the SI units of pressure? First you should know the units of the force, units of the area. When you can substitute, you will get the units of the pressure. Children, in SI system, force is measured in a Newton, area is measured in meter square. Thereby, pressure is measured in Newton per meter square. Newton per meter square. Children, this Newton per meter square is given a special name called Pascal. Is called Pascal. Whenever you are writing a symbol, capital P and a small a you can write. So, SI unit of pressure is a Pascal. Okay, fine. Now, let us see the CGS units of pressure. CGS units of pressure. Children, in a CGS system, force is measured in dyne, whereas area is measured in centimeter square. So, when you substitute dyne here, centimeter square here, then what we get? We get the CGS units of pressure, that is dyne per centimeter square. Here you may get one doubt. Sir, do we have any special name for dyne per centimeter square? No, we don't have. For SI system only, we have a special unit, that is what actually? Pascal. Whereas in the CGS unit, directly you have to write it as a dyne per centimeter square. That's fine. Children, before going to discuss what actually Pascal is, let us learn how a SI unit of the pressure is related to the CGS unit of the pressure. Okay. So, just try to copy it. Have you copied? Just take a notes. Copy it. Yes. Done. Fine. Now, we discuss how SI unit of a pressure is related to the CGS unit of pressure, children. So, look at here. What is that here? So, in a SI system, of course, Newton per meter square. So, in exam, they may ask you, 1 Newton per meter square is equal to how many dyne per centimeter square, or 1 dyne per centimeter square is equal to how many Newton per meter square. Children, it's a very important. Let us see, children. So before that, we should have an idea about of how a Newton is related to dyne, how meter is related to the centimeter. Let us recall once again, children. So we all know that 1 Newton is equal to 10 power 5 dyne, it's fine. Whereas 1 meter is equal to 100 centimeters. Children, can we write it as a 10 square centimeter? Yes, of course. As 1 meter is equal to 10 square centimeter, 1 meter square is equal to, children, can we write 10 square centimeter whole square? This can be 10 power 4 centimeter square. So it's very important. 1 meter is equal to 10 square centimeter, whereas 1 meter square is equal to 10 power 4 centimeter square. Got it? Fine. Now let us see, children. 1 Newton per meter square is equal to, in the place of Newton, you can substitute 10 power 5 dyne. Yes, 10 power 5 dyne. Meter square is equal to, we can substitute 10 power 4 centimeter square, that is 10 to the power of 4 centimeter square. So here 10 power 4, 5 will get cut. Only 110 is left. Not understanding? Yes. Let me give you clarity. 10 power 5 can be written as 10 into 10 power 4 dynes, whereas this is 10 power 4 centimeter square. So this 10 power 4, 10 power will get cancelled. So here we got 1 Newton per meter square is equal to 10 dyne per centimeter square. Very important. Or 1 dyne per centimeter square is equal, children. What happens? This 10 will go this side, means it will become 1 by 10. 1 by 10 is how much? 0.1. 0.1 Newton per meter square. Got it? It's very important. 1 Newton per meter square is equal to 10 dyne per centimeter square, whereas 1 dyne per centimeter square is equal to 0.1 Newton per meter square. Just copy it. Fine. Now we discuss Pascal. So it's very important. In examination, you know how they will ask the question? Define the SI unit of pressure. So it's very important. Kindly note down. Very important. Define the SI unit of pressure. So first you should know what actually SI unit of pressure is. What actually Pascal. Children, it's very important. That is, of course, we should not write a P as a capital. This Pascal definition we are going to discuss. Pascal symbol can be PA. Children, it's very important. See here, let us take, children, here is surface, it's a 1 meter length, and here is 1 meter width. Means what is the area here? Of course, 1 meter square. Okay, fine. Now here is force acting perpendicular to surface. It's called thrust. How much thrust acting? If the thrust acting is 1 Newton, children, very important. Yes, then it is over. How much thrust is acting? 1 Newton. That is, if F is equal to 1 Newton, A is equal to 1 meter square. Children, it's very important. Let us recall P is equal to F by A. That is 1 Newton per meter square. It is called Pascal. Over. So how to define a Pascal? What is a Pascal? Children, if a thrust of 1 Newton is acting on a surface area of 1 meter square, then the pressure is equal to the 1 Pascal. Simple, children. Simple. Don't make it complicated. Let us see once again. How much thrust is acting? 1 Newton. And how much area? 1 meter square area. Then how much pressure we can say that? 1 Pascal. The force of or the thrust of 1 Newton is acting on the surface area of 1 meter square, then the pressure is said to be 1 Pascal. That's it. Okay, got it? Fine. So children, this is about force. let us recall about force. What actually force is? Sorry, pressure. Of course, I think some pressure I do have today. Okay, so it's not that actually. So whatever the pressure which we have during our work and during our daily life, that is different, and this pressure is different. Okay, children. Actually, one very important thing, we can have pressure as a lesson. We can learn a pressure, but we should not take a pressure. Okay, it's very important. Come on, what is the pressure? The force acting per unit area is called pressure. It is a scalar. The SI unit of pressure is Newton per meter square. It is also called as Pascal. The CGS unit of pressure is dyne per centimeter square. 1 Newton per meter square is equal to 10 dyne per centimeter square. Children, now we will discuss on which factors does the pressure depend. Children, it's very important. Very important. Very important. So the factors on which pressure depends, because if we can understand these factors only, the application part will become very easy. So children, look at here. So the first factor, children, let us remember this first of all. Keep in your hand, P is equal to F by A. It's very important. Okay, fine. So let me take one example so that it will become very easy to us to understand. Okay, fine. Children, here I have taken 1 meter square area, and here also I have taken 1 meter square area, which means what? Surface area remains constant. Here unit area, here unit area I have taken. Okay. On this surface, children, let us take here 2 Newton thrust is acting, whereas here let us say 3 Newton thrust is acting. Let us take, it is first surface, it is second surface. Now children, on which surface pressure is more? Come on, think. Come on, it's very simple. Children, so in both cases surface area is same. On the first surface, the thrust of 2 Newton is acting, whereas on a second surface, thrust of 3 Newton is acting. Then can you say that in which case a pressure is more, either in first case or second case? Come on children, pause the video, think. It's very simple. You can do it, don't take light. Okay, it might be a very small, but it's very important. Just is the basic point. With that only, if you are able to do this, you can understand easily on which factor does the pressure depend. Come on, got it? Chalo. Look at here. For that, let us use this formula. Let us see children. In this case, yes, F is given 2 Newton, area is given 1 meter square only. In the second case, F is given 3 Newton, whereas A is given 1 meter square. Now let us, in this case, the pressure is P1, let us say. Okay, let us say this is F1, A1, it is F2, A2. Then it is F1 by A1. So this can be 2 Newton per 1 meter square. So P1 is equal to, we got 2 Newton per meter square. Okay, fine. Now come to the second case here. So children, here P2 is equal to F2 by A2. Let us substitute here 3 Newton, it is 1 meter square. Then P2 is equal to 3 Newton per meter square. Oh, so here which one, in which case pressure is more? Yes, second case. So can you say that P2 is greater than P1? Yes, P2 is greater than P1. P2 is greater than P1. Can I say? Let me write here. P2 is greater than P1. Since F2 is greater than F1, children, so very important. Yes. So here, what is that factor deciding the pressure? Is a thrust. More the thrust, more the pressure. Less the thrust, less the pressure. So how both are related, children? Can we say that pressure is directly proportional to force? Yes, right. You are right. Pressure is directly proportional to force for a given surface area constant. Given surface area. Okay children, fine. So in exam they may ask us how, just give one method, okay, or else how can we increase the pressure for a given surface area. If they will ask us to write, to mention how can we increase the pressure for a given surface area, you can say that by increasing the force, by increasing the thrust. By increasing the thrust, we can increase the pressure. Then how can we decrease the pressure? Yes, by decreasing the magnitude of the thrust, we can decrease the pressure acting. Okay, fine. So this is the first factor. Okay, here let me write here. What is the first factor, children? First factor is magnitude of force. Magnitude of force. How? Pressure is directly proportional to the surface area. Right? Copy it? Fine. Shall we move to the second one? Yes. So children, pressure, it's very clear that pressure is directly proportional to the force. Now let us move to the second factor. Pressure at the rate factors, right? Yes, factors. Fine. The second one, let us take a small example to understand. Okay, fine. So here children, let me take, here is surface area. Yes, here is 1 meter square and here is 1 meter square. Sorry, 1 meter, it's not 1 meter square, right? So again we have taken a unit area. Okay, fine. And here we have taken, this is 2 meter length and this is 2 meter length. It is not that always you should take 1 into 1, 2 by 2, 3 by 3. You can take 2 by 3, 3 by 4, 3 by 7, 3 by 11. It's our wish. You can take in any area. We can calculate the pressure. Okay, fine. So here is, let us say the surface area is 1 meter square. Here the surface area is 4 meters square. 4 meters square. Now children, here let us say 20 Newton thrust is acting, and here also 20 Newton thrust is acting. Let us say the first surface area, it is second surface area. Children, now in which case a pressure is more and in which case a pressure is less? Come on children, you can do this. Yes, because yes, here we have a clue. Pressure is equal to force per area. Come on children, by using this formula, by using this data, yes, you can do it. Come on, tell me. Just come on, think. Have some practice. Yes, do that. Some mathematical practice is needed here. Yes, come on. Go to the answer. Hey, don't forget to mention your answer. Okay, definitely I will respond. Okay, fine. So let us see. Yes, if my guess is right, you all might have got the correct answer. Let us check once again. Children, in this case, how much force is acting? Let us say the force acting is 20 Newton, whereas the surface area is 1 meter square. By using this formula, that is pressure, let us say P1 is equal to F1 by A1. So this will be 20 Newton by 1 meter square. So pressure is here 20 Newton per meter square. 20 Newton per meter square. Okay? Acha. Now calculate in second case. Yes. In this case children, force is equal to same force is acting. Hey, by seeing the force, don't come to the conclusion that yes, pressure is same. Because we have learned pressure is proportional. Sorry. Hey, it's wrong. None of you are seeing. Come on. Yes. If you have seen, the students who have seen, you have commented, sir, you are doing wrong here. How it is proportional to the area? No, sorry. Just I got confused. Okay. So pressure is proportional to force actually. Okay. So by knowing this, by keeping this relation in mind, and by seeing this here 20 Newton, here 20 Newton, don't come to the conclusion that pressure is same in both cases. No. Come on. Let us see here. So force is 20 Newton and surface area is 4 meters square. Okay, then the pressure is equal to 20 Newton per 4 meters square. 4 ones are 4 fives. Come on. P2 is equal to 5 Newton per meter square. Oh my God. What happened? Why we got two different answers? Yes. The reason is that the area on which force, that is thrust acting, is different. Right ones. So here P1 is greater than P2. Very important. Yes. P1 is greater than P2. Here force is same, 20 Newton, 20 Newton force. What is that factor then? Yes, surface area is different. So here, since A1 is less than A2, here we got one beautiful conclusion, children. Here, for a given force, less is the surface area, more is the pressure, and more is the surface area, less is the pressure. Which means what here? For a given force, pressure is directly proportional to the surface area. Children, very important. When force remains constant. When force remains constant. That's it. So, what is that second factor? Yes, surface area. Let us write here. Surface area. Surface area. So, pressure is inversely proportional to the surface area. Children, for a given force, how can we increase the pressure? By decreasing the surface area. For a given force, how can we decrease the pressure? By increasing the surface area. So, it's very important. So, the pressure exerted depends on two factors. One is magnitude of force, how? Directly proportional to the force. And the second factor is surface area. How? The pressure is inversely proportional to the surface area. Got it, children? Got it? Yes, very simple. Now, let us see some application part. Just copy it. Fine. So, here some applications in our daily life. We'll see some applications related to this concept. So, children, for a given force, pressure is inversely proportional to the surface area. Children, it's very important. But don't forget that here force is constant. Force is constant. Okay, fine. First one, children. Children, you are provided with two knives. One is a blunt knife, another one is a sharp knife. Which one will you pick up to cut the vegetables? Tell me, blunt knife or sharp knife? Then you may get one doubt. Sir, what is this? Even uneducated person also can do it. Yes, you are right. Yes, by seeing the knife only. If it is a sharpened one, yes, we can take and we can chop the onions and other vegetables. Blunt knife, we do not choose. But what is the scientific reason behind it? Scientific reason, children. So here, if you can see, sharp knife, sharp one, and another one is a blunt one. Try to understand. So, sharp one, if you can see that edges, children, the surface area is very less. Very important. Less surface area. So, less surface area, children, more pressure will act. More pressure. Whereas in the case of blunt knife, more surface area. So, obviously here, less pressure. Means you need to put more efforts to cut it. So, that is the reason why do we choose a sharp knife than blunt knife in order to cut the vegetables. Okay, fine. Now, second one, children. Dear children, first suppose there is a running competition between camel and horse, but in a desert. Can you guess which one will win? Sir, as it's very simple, we can say that obviously we can say that camel can run faster than horse in a desert. What could be the reason, children? It's very important. Of course, again, it is the concept of surface area only. Children, if you can notice the feet of the camel, its feet is broad, right? Means the area of the camel, area of the foot of the camel is a very high. It's very large. As a surface area is large, the surface area of the foot of the camel is large. What happens? less pressure acts. That's what will happen. Camel feet cannot go into the sand. It cannot sink, I can say that. Whereas horse foot, if you can say its foot, its surface area is less, more pressure will act, it will go inside of the sand. So it cannot run faster than camel. Again, it is a matter of what, dear children? Yes, surface area. More the surface area, less the pressure. Okay, fine. And third one, children, if you can notice rail track, yes, it will be like this, rail track. Okay, na? And you might have noticed that, children, under this rail track, you know, this wooden sleepers will be there like this. Wooden sleepers will be there. Number of wooden sleepers will be there like this. These are the wooden sleepers. Not above the rail track. Okay, na? Just it is below the rail track. Why these are provided? It's very important. Dear children, if these are not provided, let us think. Then what happens? We know that train has more weight. It's a very heavy weight. So it exerts so much of thrust, let us say force, on this track, so that what will happen, as the surface area of the track is a very less, is very less, so more pressure acts on it, then track may get disturbed, then train cannot go properly, accidents may take place. Okay, then here, as we are providing this wooden sleepers, children, look at the surface area. Together this all will provide large surface area, thereby pressure acting on rail track is decreased. Okay, children, this is a very important. Very important. Okay, children. So these are the few applications, means in exam how they will ask you the question. Children, let us recall once again what we have discussed in today's class. Children, today first we have discussed about thrust. What is thrust, dear children? The force acting perpendicular to the surface is called thrust, and thrust is a vector quantity. Its SI units are Newton and the CG units are Dyne. And here thrust, what we can say, effect of thrust depends on the surface area. More the surface area, less the impact. Less the surface area, more the impact. Then we discuss the pressure. What is the pressure, children? The thrust acting per unit area is called pressure. Its SI units are Newton per meter square and the CGS units are Dyne per centimeter square. And pressure depends on two factors. Oh, here it is rubbed up. Okay, fine. So pressure depends on the two factors. One is what, children? Force. That is, pressure is directly proportional to force for a given surface area. But whereas pressure is inversely proportional to surface area for a given force. Okay, P is proportional to F, P is inversely proportional to the A. Okay, children, thank you so much. All the very best.